Welcome to a lesson with Dr. Powell. Let's take a look at Kruskal's algorithm and what it does. So it finds the minimal spanning tree of an undirected graph with weighted edges. And the process is to first list out all the edges and sort them. We'll name the edges by their weights and maybe with subscripts to distinguish. 2A, B, 3A, 3B. So listing these out, maybe we could have 1A, 1B, 1C, and 2A, 2B, 3A, 3B. So we're going to be going through this list of edges. And once we come to an edge, we check to see if it's a loop. If it's not a loop, then we'll do two things. We'll add it to the solution. We've used it. And we pinch it, meaning we make it into a loop. So we merge the two vertices right here together. So looks like all these guys will now be one, united. And here's 1A as a loop. Okay, then, or, potentially, I guess, since we're done with 1A, we could just get rid of it. Okay, and we can keep going. So now, yeah, we could just kind of push it together even here. So we check to see if it's a loop. So the next one, check to see if it's a loop. It's not a loop. So we add it to the solution and we pinch it, which I suppose we could just kind of make it non-existent and just run the things together like this. That would work. All right, so that's what we're doing. So we check to see if it's a loop, and if it's not a loop, we pinch it like that. Okay, so we just use 1B. Now we go to 1C, the next guy in the list. It's not a loop, so we pinch it. All right, and throw it out of existence here. So this is really just, okay, round that off a little bit. All right, so it looks like we've used 1C. Okay, next we go to 2A, not a loop, so we use it. And we pinch it. Now when we pinch it this time, looks like it throws everything to be a loop. So as we go through the list of edges, we won't use anything else. And there's our solution, minimal spanning tree. Complexity, well, first we just sort the list of edges, then we traverse them. Traversing them is like number of edges. And sorting them is E, so E is number of edges, E log E. Take big O of that, add those together, and this trumps that other one. So really we're looking at O, E log E, where E is the number of edges. Now the number of edges, if we assume that this graph, undirected graph, is simple, that means the most you can have between any two vertices is one edge. So at worst, you have a complete case where you have, for every two vertices, you have an edge, which would be like n choose 2, which is a polynomial in n squared, which means that the number of edges is O(n) squared. So this really should look like n squared log n squared. However, right here with the logarithm, this 2 can come up front, very nice, swallowed up in O. So we're really looking at complexity of O n squared log n for Kruskal's algorithm. Thanks for watching.